If I knew, hello? Can you hear me?
Me? Yes, I can hear you.
Yes, okay. I had problem
I think,
with the other headset, so I had to change it. This one is better, I think.
great. Okay, I think we can start now. So welcome everybody to today's webinar and welcome especially Dr. Momuni Yakuba from the University of Nevada, Las Vegas. So we are very happy to have you here today and give your presentation on energy infrastructures, gateways to the future of energy. And before I would like you to introduce yourself to the participants, I shortly want to give you an overview on the background of the participants themselves. So they are mostly master students from our partner institutions or universities in Mali, Niger, Algeria, and Germany, and have diverse background in fields such as water management, energy, geography, physics, chemistry, biology, environmental science, or related fields. So just that you have a brief background of the participants. And now I would like you maybe to start by introducing yourself before you start with your presentation.
There's a background noise. There's a background noise when you were talking. Is it students talking or?
Maybe it's my colleague. I will switch off my microphone
Okay.
so that we won't get this.
Please. Thank you very much. Thank you very much. So, hey, welcome everyone. My name is Mumuni Yakuba. Again, I'll go over a brief biography. I had a bachelor's degree in electrical and computer engineering back in 2000, and then I got a Fulbright scholarship to go to America to get a master's degree in mechanical engineering. I would say electromechanical because it was basically focused on energy, but I had the chance to take electrical and mechanical courses at the same time. Then after the master's degree, I had the opportunity to continue to finish my studies. I got a PhD this time in electrical engineering, focusing in energy, renewable energy, thermoelectric generation, and things like that. So briefly, and then I started to work there as not a postdoc, like part-time professor, part-time teacher. Then I got opportunity to come here in the United Arab Emirates, where I'm currently here as an assistant professor, focusing again teaching electrical courses and also doing some research. So briefly, this is all about me. And without further ado, I will start the presentation. And the key question I ask and is about the language. I would like people to step in if they think it's difficult for them to understand the English. Please, they should raise concern. Earlier the better. I will try my best also to explain some key concepts in French. I know it's difficult for me because the presentation, I'd rather, if I knew I had, I would present everything. I would prepare the slides in French. That would help me to go over it in French. It's easier. Translation is not an easy, to go from one language to another language. But I will try my best again. So the content of the presentation, I don't want to spend time on the content, so I'm going to talk about the concept of energy first. Briefly, this is, like an introduction. We'll talk about that. I will spend time on the infrastructure. Also, the 7 sub-themes of urban energy infrastructure. I will try my best to go over the 7 sub-themes in conclusion, and then followed by questions and answer session at the very end of the presentation. So first of all, what is energy? What do we understand by energy when we say energy? What comes to our mind from primary school, from middle school? qu'est-ce que c'est que l'énergie? Qu'est-ce qui nous vient en tête quand on dit énergie? So in English, it is the energy, the ability to do work. Je pense bien que c'est la même définition même en français. C'est une définition très simple que tout le monde, à partir du collège, on peut comprendre, on peut, je sais pas, on peut définir l'énergie d'une manière très simple. Maintenant, si on rentre dans les détails, c'est autre chose parce que l'énergie en tant que telle, a plusieurs formes. Now, what are the forms of energy? What are the forms of energy? As you can see here, we can talk about thermal, we can talk about radiant, we can talk about motion, we can talk about electrical, nuclear. And then on the other hand here, we have the two broad categories. The two broad categories of energy can be categorized in the form of potential or kinetic. Kinetic, c'est ça, l'énergie cinétique. L'énergie, donc les deux grandes catégories, les deux grandes catégories, c'est en fait l'énergie potentielle et l'énergie cinétique. Donc les autres énergies dont j'ai parlé, donc heat, all the way to gravitational, can fall into one of these categories. Je sais que c'est pas facile de présenter en anglais, lire en anglais, présenter en français, je sais, mais je ferai de mon mieux quand même. Donc, energy can further be divided into renewable or non-renewable. Today, everyone knows about when we say renewable energy, we know that it's a source of energy that can be replenished at a human scale. C'est les formes d'énergie que nous sommes amenés à développer pour le futur de l'Afrique, pour le futur du monde, pour le futur de nos enfants. Donc, les énergies renouvelables. Et les énergies non renouvelables, donc non-renewable energy resources, which are the sources that are depleting. And they are the sources that are causing more harm to the environment today. Okay? And we can also categorize energy in two broad categories. We have high-grade energies and low-grade energies. What are the high-grade energies? In terms of definition, it's a form of energy that can be converted under certain, let's say, the percentage of conversion is not that great, it's not that significant. So examples of that would be heat energy, wind energy, sound energy. They are the form of energies that we can categorize as low energy, grade energy, and we know wind, how much can we convert from wind energy? We know Betts theory, Betts law. Betts say that energy, you can only convert energy, wind energy, to 2/3 of its category, of its capacity, 2/3, which is approximately 59%. And under that 59%, if you look closely, you will see that the conversion, the percentage that you can capture from that 59% depends on the infrastructure that you have. Which kind of wind turbine you have. Is it an efficient wind turbine? Is it a homemade wind turbine? Is it a commercial wind turbine? That will also cut down some of the percentage. So you will end up with having 30%, 35%, 40%, not more than 45%, I would say. And then on the right-hand side, you have what is called high-grade energies. These are the form of energies that you can utilize 100%. You'll be able to completely convert them 100%. And what are they exactly? What are the examples that I chose? We have 3 examples. Electricity. Electricity, you can see in your house, in everywhere, you can convert it like 100%. You can make it like a useful. Like the light here. I am here under light. This light is a form of electricity, is a useful form of energy, which is, you can see it's like almost 100%. So we have also mechanical, and then we also have the last one is water power. So we cannot talk about the energy infrastructure without talking about sustainability, without talking about resilience and efficiency. So sustainability mes frères francophones, donc sustainability, c'est ça le développement durable. Le développement durable, c'est ça ce qu'on appelle en anglais sustainability. And then you have resilience. Resilience, c'est, how do I define? Resilience is the capacity of a system to recover after a major disturbance. It's called resilience. Même en français, je pense bien c'est résilience. On appelle ça résilience. Je ne suis pas sûr, mais bon, resilience in English or in power industry is the ability or the capacity of the system to recover after a major disturbance. Efficiency is the same. So, as in French, on parle de rendement, de efficiency, rendement. Sustainable, okay, sustainability, resilience, and efficiency are fundamental, okay, considerations in for city managers. Why are they important? That's the question. Why are they important? If you look today, we have almost 50% of the population, 50%. Some sites, I mean, some articles are talking about 54%, but most likely 50% and above of the population today is living in the cities. If you have 50% living in the cities, and how big is the country? Think about that. What do we need? We need to plan. We need to make sure we use sustainable energy. We need to make sure our system, our infrastructure is resilient. Why? Because we can see if it doesn't happen in our countries, it happens somewhere else where you have hurricanes, you have major severe weather events like les tornades, les ouragans et autres. Donc, quand ça arrive, qu'est-ce qui se passe? En réalité, le système peut être, la distribution de l'énergie peut être interrompue, que ce soit le gaz, que ce soit le pétrole, que ce soit l'électricité peut être interrompue pour une raison ou une autre. Maintenant, if we don't have a système qui est solide, un système qui peut I'm going to switch to English, a robust system that can quickly spring back and go back. And for that to happen, it has to have some guidelines. It has to have like some major power system, I mean generation systems to be able to do that, to be resilient. We'll talk more about the resilience. So I don't want to spend too much time on the resilience here. And the third one is, again, urbanization, okay, is expected to continue. And it's going to continue because we're witnessing every single day that our cities are being, let's say, countryside, people living in the countryside are moving more and more toward the cities. So everyone is moving to the city. Everyone would like to be part of the city. Why? Because of the abundance of facilities. So what's going to happen? This will create more challenges, more problems for power companies or energy companies in general. Okay. And then we move on. This is another slide showing here. This is a double slide actually, showing the density of the population. You can see that some places like the Indian subcontinent, you can see that you have all the way to China, to Japan. You can see that those places are densely populated compared to, let's say, Africa. And this tells us what, in terms of energy consumption, it's a major challenge. If you think about India, for example, it's a major challenge. It's still a major challenge for the country. Okay. We move on to here again. Since we're talking about resilience, this graph shows the matrix, the resilience, sustainability, the resilience sustainable infrastructure metrics. And the metrics on the left-hand side, when you look at the left-hand side, you can see that you have a low to high. The environmental footprint varies from low to high. And at the bottom, you have the resilient, which also varies from low to high. At the beginning here, low to low, you have the status quo. And then as you move in on the y-axis, you can see that the environmental footprint reduction becomes important. When it becomes important, we care about the ecosystem, we care about the environment, so it becomes greener. When it becomes greener, we keep it there. I want to be there, so it's really important that we keep that in mind. It's greener. What is greener? When it's greener, we know what is happening in terms of fresh air, in terms of fresh water, in terms of the quality of the air, in terms of the soil. We know what is happening. And then we look at this on the x-axis, we have the resilience. The resilience from the status quo, we move on to a robust system. A system that is robust is a system that is able to spring back after a major disturbance happened. And what is the major disturbance? It could be power outage, it could be hurricanes, it could be a lot of natural weather events, severe weather event that could be considered as kind of as a disturbance. And then on top of that, at a high environmental footprint reduction and the high resilience, which is robust, you will find there the resilient, sustainable infrastructure. So we're going to talk about infrastructure more and more about the infrastructure. And then here we have major components of how to assess. We can see here, this slide talks about the assessment of the urban energy resilience. How do we assess it? On top of this chart, we have the sustainability and resilience of energy system. Right below that, we have 4 dimensions. The 4 dimensions are availability, accessibility, affordability, and acceptability. Those are the 4 dimensions. The 4 dimensions of sustainability, of course. And then from the 4 dimensions of sustainability, we can talk about the abilities. What are the abilities that we have? What are our abilities? Preparation, planning, absorb, recover, adapt. All these we're talking about when something major happens. These are things that we need to do to prepare for the worst case scenario. If the worst case scenario happens, how do we absorb? How do we recover? How do we adapt? And how do we go back and prepare? And then at the bottom here, the pink colors, you can see it's talking about the principles. So I don't want to spend that much time on the principles, as time is critical. So, importance of energy in our lives. How do we feel about energy today? It could be energy in a broad term. How do we feel? How do we see our lives today without energy? Can we imagine every single instance that, today if we go back to a level where there's no energy, what's going to happen to our life? You can see the pictures here. You can see that everything in the city is drawn around energy. You can see the cars, you can see the TVs, you can see people. Without energy, that's not going to happen. We know what is going to happen without energy today. Okay? So, nation's economy is increasingly dependent on affordable and reliable supply of energy. What is affordable source of energy? What is reliable source of energy? An energy which is reliable is a source of energy that is uninterruptible, energy that is there forever. I wouldn't say forever, but whenever we need it, it's there. I enter my room, okay, the switch is there. Do I think if I hit the switch, the light will come on? If the power company in my country is reliable, I don't even think about that. I just hit the switch and the light is there. Because that's how it's supposed to be. If the power company if the supply of the energy is reliable. Now, affordable, that's another term, affordable. How many people can afford the electricity? How many people can afford the energy? How can we make it affordable to everyone? How can we get, give equal opportunity to people to get the energy, without feeling the financial burden? So that's briefly summarizing the impact, the importance of energy in our lives. Energy is everything today in our life. the economy, the four major economic sector, everything is drawn, again, as I said, everything is around energy. Without energy, nothing would happen. So now we come to our topic. The topic of today is energy infrastructure. What is energy infrastructure? I would go with this definition. I will just read the definition for you. It says EIA. This is EIA is Institute of Energy Administration. The Institute of Energy Administration, which is a body of 30 countries. 30 countries. Most of the countries are the developed countries today. None of the African countries are in the EIA administration. Okay, so EIA administration defines energy infrastructure as the large-scale enabling technologies to, first, three of them. One, transport energy from the consumer, from the producer to the consumer. So from the production, which is the power plants. The power plants, if we talk about electricity. If we don't talk about electricity, we talk about oil, from the production oil to the consumers. And then two, direct the energy flow. Three, manage the energy flow. How do power companies or oil companies distribute the energy flow? How do they manage the energy flow? That's basically the definition of IEA. And then we look on the right-hand side. Right-hand side, this is coming from the EIA. EIA is the Energy Information Administration. This is from the US, and this defines the energy as the gate, the bridge between the primary energy production and the energy consumption. In between, you have the energy infrastructure, as you can see here in the red rectangle. You can see it in the red rectangle. Do people see my pointer? Do you see my pointer when I point? Do you see it? Hello?
Not right now. Maybe you select the pointer. Have you selected it?
How can I select the pointer? Because I want to point at things. How can I select it?
Did you click it? Like I did now.
Okay. Which one is the point?
Next to there's draw and stop sharing, and in the middle there's a pointer.
Next to what?
On the right-hand margin, if you go up.
Up. Right-hand margin.
Upper right corner.
Upper right corner.
There's an arrow next to the draw sign.
Oh yes, I can see it now. Yes, thank you very much.
Yeah, here we go. I can see it now.
Yes. So if we're in a point, I just draw it, right? Like this.
Yes, exactly.
Okay, good. Thank you very much. Thank you. So let's continue, please. So now I think we kind of understand the definition, what is energy infrastructure? We have the production on one side, we have the consumption at the end, which is the downstream, and in between we have what is called energy infrastructure. So energy infrastructure can also include the following. We have three of them. We have everything from the transportation perspective, like a coal, transportation, natural gas, electricity. So electricity, basically what people are familiar with is the transmission lines. Also can include everything like what we have today. We have today more and more, we are moving more and more to a smart infrastructure. And one of the instances of smart infrastructure is the advanced metering infrastructure. So advanced metering infrastructure is a broad term. Inside the advanced metering infrastructure, we will see later on that we have different items there that we need to talk about when we talk about the energy infrastructure. We have the distribution system, we have the smart building technology, modern power plants control systems. And also we have, in the energy infrastructure, we can talk about the interconnect. We already talked about the interconnect. So let's move on to the next slide. Okay? So how do we understand energy infrastructure? Or how do we understand the urban energy infrastructure? Because the focus is more and more, if you look, I'm taking it from the broad concept to bring it to the narrow concept. Now I'm going to the urban side, okay? So again, the population is the major drive for energy consumption, and population is what makes cities to become what they are today. Population is one of the key concepts that we need to take into consideration when we want to assess the amount of energy that is being consumed in an area. So an energy system is a socio-technical system. It's more than just the infrastructure that we see. It's comprised of more than just the pipelines. It's everything around the energy, everything that consumes the energy, everything that participates in the design of the energy can be part of that infrastructure, because the infrastructure is built for certain community. The infrastructure is built for certain people. If we don't take the people, their needs, because if we're talking about, an instance is like the per capita energy consumption. If we're talking about African countries, not that I'm belittling African countries, no. It's because of their level of development in terms of energy consumption. And you compare that to countries like the United States of America or the UAE or the European countries in terms of per capita, you can see that, it's, the energy infrastructure in the developed countries or the countries with higher per capita is much more designed in a robust way, because a minor disaster there can create, a minor problem can create a disaster. On the other side, people with less energy per capita, even if there's a problem with the energy infrastructure, the people, they're so used to live naturally that they would not be that much affected. They can, I wouldn't go and say that they can live without electricity, no, but they can survive even without electricity. They can sleep. For example, let's talk about the AC. Some countries, people cannot sleep without AC or without cooling or without heating. Most African countries, I wouldn't go to the south or up to the north, but most African countries, you can see people sleep naturally without ventilation, without anything. So markets is one of the things that we need to consider. Consumer behavior is one of the things that we need to consider when we talk about energy infrastructure. Those are key components that we're going to talk more about. Urban energy system, therefore, need to be viewed more widely to account for local context. The local context, again, I was trying to explain the local context. It's very important. If we talk about the north, if we talk about the south, the local concept is a key concept that we need to consider, when we talk about the energy infrastructure. So again, what are the major categories of energy infrastructure? Let's look at them together. We have the oil infrastructure, we have the natural gas, and then we have the electricity. So I'm going to focus more and more on these, and I'm going to go, as you can see, from oil, natural gas to electricity. You can see I'm drawing closer and closer and closer to the cities. So you will see I will talk more about electricity at the end. Okay, so oil infrastructure, you can see the images here. Yes, let me use the images here. Everything starts from here. You have the crude oil. From the crude oil, now we go to the pipeline, the transportation. From the transportation, it brings it to the refinery. From the refinery, then you take the end product, the final product, to the end users. So let's look at that on the side. We have three major components for oil and natural gas. I just chose to make them together to save time, so oil and natural gas, we have upstream, we have midstream, and then we have the downstream components. Again, pipelines and other transport system can be used to move crude oil, as we know, to the downstream. So let's move on to the next slide. So what is the upstream? What is the midstream? What is the downstream? Again, in a nutshell, I'm just going to try, I'm not, because for the sake of the time, I'm just going to go over everything. So the upstream, again, is everything from the prospect, from the drilling of the crude oil, okay, that's the upstream. The midstream here is everything from the transportation, the pipelines, okay, all the way to wholesale marketing. So the wholesale marketing of crude oil is just like what is called, in French, they call it like les grossistes, la vente en gros, la vente en gros. Donc, c'est ça en fait, donc, the wholesale marketing. And then the last piece is downstream. The downstream is the refinery of the petroleum, as well as the marketing and distribution of the products. That's the downstream. So again, we have the upstream, the midstream, and the downstream. Again, the downstream again could be everything that we consume today in the urban area, the end product that the layperson knows in terms of energy. We're talking about fuel, we're talking about gasoline, we're talking about lubricants, we're talking about asphalt. Almost everyone knows about them. So that's the downstream part of it. Then the natural gas. So I kind of take the natural gas a little bit, different from the oil, but most likely natural gas and oil, without the transportation, they're all almost the same in terms of drilling, the same process, going through the same process, because they're next to each other somehow. Okay, natural gas infrastructure refers to the pipelines. As you can see in the pictures here, you can see the pipelines. You can talk about the compressors. We can talk about the distribution system, the compressors. Again, you can see here in this, this is one of them here, as you can see here. And here it's more like at the distribution center where the pipeline, the bigger pipeline will bring it to here, and then the gas will be treated. And then so after the treatment, to separate some of the liquids and things like that, then it will go through the consumer, through the distribution system. So the storage, the metering, the compressors. So underground facility, also sometimes underground. Why? Because with the underground facility or with the storage, this helps the utility owners, the utility companies to fight against peak. When there's a peak, only with the storage you can fight peak. Without a storage system, there's no way utility companies will be able to cope with peak when it happens. So what are the key infrastructure components for natural gas that we need to understand? We have the gathering pipeline. We talk about the pipelines, the processing facility, the storage units, the intra or interstate pipelines. So this, again, most of us in Mali or in Niger, these are things that we don't know, because our gas, the system as it is currently, we don't have the system of pipeline. We don't have the system of pipeline. What we have is we have the natural gas or the cooking gas in small containers, in the small containers. That's what we have. And we have people, with trucks distributing them, or we go sometimes to buy them ourselves. So that's what we have. But in most developed countries, you have a distribution system for gas. The same way that you have a distribution system for electricity or water, you have a distribution system for gas. Hopefully, we'll see that happen soon. So electricity infrastructure is the one I would like to spend much time on it. The electricity infrastructure, again, the electricity infrastructure consists of mainly 4 major components before. The 4 major components are we have the generation, we have the transmission, we have the distribution, and before the distribution, we have the power stations, we have the substations. But today we have a new paradigm. What's the new paradigm? We need to account for storage. We need to put storage system in that infrastructure, because most likely in some countries like USA, the power companies or the utility companies they have mandates to have some sort of energy storage system at their substations. Hopefully we'll see that happen more and more in Africa as well. And also we have the last part here is the consumption management methodologies. So these are the major components of the electricity infrastructure. We can spend time talking about each one of them, can take a semester. Production, which is the generation. Transmission is a course by itself. Distribution is a course by itself. Storage system can be a course by itself. So we're just going to touch them, slightly, and just for the sake of it, give the information to the attendees. So the distribution system, again, as I said, I'm drawing near the urban area, near the consumers, near the end users, because the focus is the urban infrastructure. As you can see, the distribution system can be categorized as primary or secondary distribution system. The primary distribution system, it goes from this, again, it depends on the country. I'm not saying what is valid in America might not be valid in Niger. What is valid in France might not be valid in Niger, again, or Mali. So from 11 kV all the way to 66 kV. And then we can talk about the secondary distribution system, which is a three-phase, 4 wires. It can go from 0.6 kV, which is 600 or 400 in some countries, all the way to 230, or sometimes down, because if we're talking about the American standard, then we're not going to talk about 230, we're going to talk about, let's say, 110 or 120 volts, for example. The distribution system can also be classified as overhead distribution system or underground. So H1, again, we can spend time talking about overhead or underground. What are the benefits of the overhead compared to the underground, or what are the benefits of, again, of one versus the other one? So we can see the images here. This, as you can tell, it's underground. And the bottom one is, let's go back. I would like to explain something. The bottom one is transmission, is overhead. So let's take this. This is much more expensive, way expensive compared to the overhead. But what is the advantage? In a city where people are looking to expand the city, people are looking to make the city look nice. You can see that everything is happening underneath. So which means you will have a room to erect the buildings. You will have a room to do the fancy constructions without obstructions. And technical point of view is the capacitance and inductance. When you go for underground, the limitation is the spacing, the limitation is the distance between the phases, the lines. Then what's going to happen? The capacitance will be important in this case. And then the inductance will be low. And we know the importance of capacitance and inductance in terms of power loss, in terms of how much you can lose, and in terms of reactive power. At the bottom here, it's the opposite. For overhead transmission system, you can see that the capacitance will be low and the inductance will be important. Why? Because lines, they have inductance between themselves. They have self-inductance, they have mutual inductance. But what's going to happen is that because in some countries, the distribution system is done with bare cables. The cables are not covered, are not insulated. So you need to provide like margins. You need to make sure that the lines or the phases are further apart, so that insulation, the air becomes the insulation. But when you do that, what happens in terms of capacitance and what happens in terms of inductance? The inductance will be important. Again, here is talking about fact here. I like to mention some fact. Cables are more competitive, as I already said that, in suburban residential areas. Again, here we can classify the distribution system in terms of old system on the left-hand side and new system on the right-hand side. What is the old system? In the old system, if you look closely, you will see that there's no energy storage system in the old system at the customer premises. The customer premises, which is, you can see a customer, so there's no energy storage system. There's no distributed energy resources. What are the distributed energy resources? Ce sont j'aimerais vraiment, j'aimerais faire donc expliquer en français, mais c'est un peu difficile pour moi parce que quand je fais la présentation, my mind is kind of switch off. My mind is kind of switch off and locked to the English. Mais c'est pas facile. J'essaie de mon mieux d'expliquer. Ici, quand vous regardez ce qui se passe ici, quand vous comparez donc à l'image qui se trouve à droite, vous allez voir que dans le nouveau système de distribution de l'électricité, vous regardez, vous avez donc des batteries, des batteries. Et quand vous regardez ici, au niveau aussi des abonnés, vous avez de l'énergie donc renouvelable, donc l'énergie photovoltaïque, vous avez souvent de l'éolienne et tout ça là. Dans l'ancien modèle, il n'y avait pas ça. Donc c'est just to tell you that this is an update. We need to account for that when we talk about the infrastructure. And this is called distributed storage and generation, which is basically from the beginning of the power industry during the time of Thomas Edison, electricity before was distributed. Then electricity was gathered. And now we're going back to the distributed energy storages in countries where the law allows you to have your own PV system, for example. In some countries, it's still a headache. In some countries, it's encouraged to have your own distributed energy resources because you help the power company in terms of peak. You help the power company. We will talk about that. So production side technologies, what are the technologies that we can talk about? You can look here, we can see that we have the generators, we have the transformers, we have the transmission lines, we have the metering infrastructure, we have the electronics. All these, together, if we put them all together, it forms what is called the grid, the electric grid. What is the grid? In French, c'est ce qu'on appelle le réseau électrique. The grid in English, c'est ce qu'on appelle le réseau électrique. And the réseau électrique, again, this consists of, again, as I said, 4 major components. And then you can have more components today come into the electric grid. But formerly, we had 4 major components. We had the generation, transmission, substations, and distribution. Those are the major components. Key elements here also to take away. What are the key elements? When you look at that, we already talked about that. From the generation, it goes from the generation here. Okay, it goes to the transformers. Okay, the transmission lines, the substations, and then we go to the distribution system. These are, I think, the key components, key elements to take away from this. And then what are the problems and what are the solutions that we can talk about? The current problem with the grid includes lack of extra high voltage transmission lines, inefficient grid operation features, and lack of customizability are addressed with the grid, the concept of smart grid. The smart grid, as I said again, it's a good thing. We're still lagging behind. For us to be able to master the smart grid, although it's beyond this presentation, we need to have a strong communication system. We have to have a strong infrastructure to be able to be in that mode. Okay, so what is the definition of smart grid? The smart grid, we have all the electrical infrastructure And on top of the electrical infrastructure, you have to have a smart digital communication system. Why do we have to have that? Because in the concept of the smart grid, what happens is that the appliances would be able to communicate in a household with each other. The appliances would be able, again, to communicate with the grid operators. The grid operator would be able to oversee the appliances, to be able to have a hands-on the grid appliances. If there is a peak, the grid operator may choose to switch off an appliance, for example. That also, if we look, in the privacy point of view, that can be something that people argue that this is kind of, it can be a privacy violation, because someone in a remote area will take control of your appliances or your fridge, of your AC, things like that in your household. So if you plug in your electric vehicle, someone in a far remote area may take control of your smart vehicle. And this is the concept of smart grid. So this, again, I wouldn't go further and talk about that, although this slide is talking about the smart grid. So how does someone in the far remote area will take control of your vehicle, smart vehicle? This will only happen when you are charging your vehicle. Let's say nighttime, you leave your vehicle. What's going to happen? If there's any major issue, with the grid, inside your vehicle, you know that you have batteries. And the batteries, as you can see here, we have energy storage system here as well. Energy storage system. So energy storage system, the grid, in the term of grid, smart grid, there's no difference between the energy storage system and the vehicle. They both can be asked to discharge. They both can be asked to participate in terms of peak, in case there is a peak demand. They both can be asked to discharge some of their energy onto the grid. So again, if you look closely, we have the communication system is the green line, green dotted line. You can see the communication system, and everywhere you can see that there is a communication system. Without communication system, there's no way they will be calling this grid a smart grid. Without a smart metering system, there will be no way we will call this grid a smart grid. So one of the things that we need to understand is the two-way communication, for example, between the utility and the appliances. That is very critical. And also the smart meter here, what happens is that it measures electricity. It's different from the ordinary meter that we have. It measures electricity in two ways. It could be two different meters next to each other. It could be only one meter that can measure electricity in both directions. Now, some countries like Germany, like USA, they give you either cash or they give you electricity credits that you can store if you generate more electricity than needed. So this is the concept. I don't want to go further in that. Let's continue because of the sake of the time. How is the grid set up? Again, the grid can be set up in a radial fashion, okay? Radial fashion, and the radial fashion, just like the tree where you have the branches, the electricity from the generation point of view, the electricity the voltage will be stepped up to high voltage, and then it goes through the transmission system, and then from the transmission system now the electricity will be now divided, will be not divided, will be stepped down as it moves toward the customer side, toward the consumer side. It will be stepped down. Each step it goes lower, up to a point where it becomes, let's say, 230 or 220 or 110 in some countries, or 100 in some countries. So from extra, it goes to high, medium to low voltage. So That's how it is. And you can see here there are some numbers for the extra high, medium. There are some voltages there. So I wouldn't like to spend that much time on that. I hope the concept is clear. Transmission, we cannot talk about transmission lines without talking about losses. So here, according to some sources, the losses are approximately is around 9.5%, 9.5%. And it gets higher as you are moving toward the congested areas. As you are moving toward urban areas, it gets higher and higher and higher because of some inherent inefficiencies. For transmission line, the main problem for transmission line, the main loss will come from Joule heating, which is the I squared R loss. So lifespan of some of the components, the lifespan, okay, we can talk about that just for the sake of it. As you can see here, okay, we can talk about steel. Why do we talk about that? We talk about the infrastructure. We need to understand our electricity infrastructure. We need to understand that every single element has a lifespan. If I own a utility company, I need to understand, when is coming my next investment. I need to understand that, because power companies, they are business. They are in business. They are businessmen and women. They are sitting. So they need to understand, and you can see some numbers. So I wouldn't like to go much. This one, I want to spend some time on the SCADA. I will talk about the SCADA very shortly. I will talk about the SCADA. 15 years, the SCADA. So critical energy infrastructure and their interdependencies. What is critical energy infrastructure? Because we're talking about infrastructure. What is a critical energy infrastructure? I'm going to read the definition. It says critical energy infrastructure means a system or asset of bulk power system, the incapacity or destruction of which would negatively affect the national security, the economy, the public health and safety, and any combination of such. So think about that. All the elements dealing with this would be part of the critical energy infrastructure. And you can see on the picture here that the critical energy infrastructure, you can see all of them around here. You have the blue area, you have the green area, we have the factory area. All these are part of the critical infrastructure in a country. And this critical infrastructure, okay, let me go back, sorry. The critical infrastructure today, it becomes much and much more and more, I would say more and more vulnerable because of that, because of the concept of smart grid. Because of the concept of smart grid, it becomes more and more vulnerable. Why? Think about all the information that the power companies, they store, the information, the pumps, the generators, the lines, everything is stored somewhere on internet. Think about a small kid, like a teenager, 16 years, 17 years, 18 years, in his room trying to dig into that. It's easy today with the concept of with the internet and with the technology, and that would make the infrastructure today to become much more vulnerable. Before, that wouldn't happen, but today it can happen. It can happen. People will just do it sometimes just for fun, not because they want to, but because we're talking about teenagers. Okay. So you look at here, the electricity is in the middle, and then you have all the infrastructure, transportation, petroleum, all the way down to water resources. So all these are part of the critical infrastructure of a country, of a sovereign country. Now, what is the SCADA? What is the SCADA? Again, in English is supervisory, control, and data acquisition. In French, I would say probably this is a system of control and contrôle et acquisition de données. Un système de contrôle et acquisition de données. Peut-être que je ne sais pas, c'est pas comme ça qu'on appelle ça en français. Je ne suis pas sûr. Je ne suis pas sûr, mais ça a un sens. Supervisory control and data acquisition. So what is this? What is the SCADA? What is the SCADA? The SCADA is the system of software and hardware elements that allows industrial organizations to, first, control industrial process locally and remotely, monitor, gather, and process real-time information, directly interact with devices such as sensors. We can talk about the sensors, the pumps, the valves, the motors, okay, through human and machine interface software. And you can see here we have this picture showing in a nutshell, the elements that we talk about in the SCADA. And you can see the pumps, you can see the pumps here. We have, the I/O system, the operator stations. We have, on top of that, we have what is called the historian. The historian is just an element that is used to record the information, the SCADA, because the SCADA, you should be able to store the information. And what are the major components of the SCADA? We talk about them. Major component, you have to have the sensors. Sensors, en français, c'est ça les capteurs. You have to have, il faudrait qu'on ait des capteurs. C'est avec les capteurs qu'on peut lire des informations. La température, par exemple, la température des éléments, par exemple, c'est avec des capteurs qu'on peut les lire.
This is Anna. Just to remind you that you have up to 5 to 10 minutes left.
5 to 10 minutes left?
That would be great.
Okay, 5 to 10 minutes left. So let me see what I can do. So SCADA, basically, conversion and mastering units. I will spend some time on the SCADA and then go to the conclusion then, because I cannot cover everything. Then we have what is called the communication networks. These are the major components of the SCADA system. So from now, I need to make sure what is urban energy infrastructure. So I'm just gonna, urban energy infrastructure again here. The UN and some of the major UN sub organizations, they try to define that. And if you look at the definition here, we have 3 major definitions. We have pure geographical definition, we have the geographical plus definition, we have the pure consumption. And if you look at them, these definitions, again, they somehow complement each other. Some of them are, the first one, for example, it says consists of only the technology within the boundary of the country, of the city. This one talks about the technology within the boundary plus every traceable, everything that is traceable, outside the boundary, which is like electricity flow. And then this one, the pure consumption, is talking about all the activities, of the occupants of the city. And then what is the insight? What do we take from here? The first one is too restrictive. The second one is, that omits the electricity flow arising from outside the city, which is the second one is too broad. The first one is restrictive. The second one is broad. The third one is this one is talking about the geographic plus, is defined as the urban, all the urban daily activities, in the city. Influence, capturing the influence of urban forms, economic functions, attributes of energy systems. What we understand here potentially exclude lifestyle and trade-related issues in exurban areas. What are the exurban areas? Are the areas mainly at the Bay Area or the countryside or the land farms are excluded from this definition. So the major economic sectors, I'm not going to talk about that, but I would like to talk about the energy consumption of the transportation sector is 20%. The residential sector, again, the residential sector, as I said here, is debatable. This is a debate, because it includes everything from residential, commercial, and public buildings. So the consumption is about 25 to 30%. We need to understand that because if we plan a city, we need to plan it well so that the infrastructure will be able to handle the future development. So industrial sector, again, based on some sites, it's 35%. Based on some authors, it's 38%. So I'm just going to put it 35 to 38%, the energy consumption. Okay, and these are the major sectors of the industrial sector, mining all the way to that. And then on top of that, the steel, iron, steel, and the chemical industry represents half of the energy consumption of the industrial sector. Smart building, I would not talk about smart building. I will skip the smart building, okay? I'd like to talk about the themes, the 7 sub-themes. Use of global urban energy, yes, this is important. How much energy are we using in the cities? How much energy are we using? Now we know the infrastructure. It's about 50% of the population on the whole world, 50 to 55% or 54% today resides in the cities. How much energy are we using? 2/3 to 3/4 of the global energy is being used in the cities. And again, this is something that we have no scientific data to back it up. It's just some, people estimating that. For countries, yes, I can know exactly for my country what is happening, but for global consumption, it's not an easy thing. This one, I will just skip this. This graph shows the world energy demand per cities and by fuel. So you can see, that is what is happening. The trend is, I'm just going to point out the trend. What is happening is that if you look at from 2006 all the way to 2030, which is going to come soon, you can see that the electricity consumption is just increasing. It's just increasing. Likewise for oil, likewise for gas, all of them you can see that there is an increase. But on the other hand, we can see that the fossil fuels are just depleting. So where are we going to get this energy? More population, more energy, but the fossil fuels are going down. And we know our major energy resources, our major consumption today is coming from fossil fuels. So what is going to happen? What's going to happen in the future if we don't change our habit today? Those are just rhetorical questions. I'm just asking, those are rhetorical questions. So the seven sub-themes of urban energy infrastructure, we can see from supply, distribution, backup, storage, infrastructure, green infrastructure, blue infrastructure, buildings and neighborhood, transportation, and finally, innovation. So each one we can spend time talking about them, but for the sake of the time, we will not have time to talk about them. I'd like to go to the conclusion. So what is the topic says gateway to energy future. What is the future of energy? What is the future? This is a question I can ask all the participants. What is the future of energy? What's going to happen in the future? What can we do today to make sure that our kids tomorrow will have the same luxury that we have? What can we do to make sure that they also meet their like a daily energy demand without struggle? What can we do? So concepts, things that we can do today, I think we can talk about efficiency, and that has to be on the technological point of view. We can talk about conservation. We can talk about conversion. We can talk about saving energy. Those are the key points that we need to think about today. Also, it says improved. What we can do is to change the way we build our houses. we can also change the way we design our cars. And you can see change is coming. It's slow. Humans are resistant to change, but it's coming, because today we can see that we have hybrid electric cars, we have electric cars, and we have even solar cars today coming. So the efficiency, of course, is low, but slowly with breakthrough in the technology, we can see more and more of these, technologies coming on board. Okay, so what can we do? Again, I'm asking, this is a rhetoric question again. What can we do? As an individual, start with what you have. Start where you are with what you have. I can decide to walk, for example, to come to my work if it's close by. I can decide, if we are 3 friends, we can decide to carpool. Instead of driving every single one of us our cars, we can decide to come together. Carpool means, en français, je ne sais pas, carpool, c'est-à-dire conduire une seule voiture. Si vous êtes 4, vous avez 4 voitures, donc vous décidez de conduire une seule voiture. C'est-à-dire vous décidez, comment je vais dire, c'est-à-dire à tour de rôle, quoi. Si aujourd'hui je viens avec ma voiture, donc on vient ensemble, demain on vient avec la voiture de X, Y, Z, and so on and so forth. Donc c'est ça, carpool. Those are strategies that we can adopt today to save, the environment, and also to make sure that, the concept of sustainability is applied locally, regionally, and globally. Energy efficiency and renewable energy are the twin pillars of any sustainable energy policy. So sometimes, as an individual, I don't have a say. I don't have the authority to say, this is what's supposed to be done. But then what can we do is to advise the investors, is to advise the utility owners, is to advise the stakeholders, is to advise the lawmakers. We, as a technician, we need to inform them, and the decision is theirs. And the only way they're going to listen to us is when we talk to them about the economics. We talk to them about what they're going to gain, what the country will gain. Then they will listen to us. Parce que quand vous parlez avec quelqu'un qui a un esprit de business, il faudrait lui parler en termes d'argent, en termes financiers. Quelles sont les retombées? Qu'est-ce que lui, il va gagner? Qu'est-ce que le pays va gagner? Qu'est-ce que ceux qui sont dans la sphère de l'énergie, qu'est-ce qu'ils vont gagner? Qu'est-ce que le pays va gagner? C'est des choses comme ça qu'on va faire pour c'est-à-dire, that's how we're going to change their mentality. That's the only way we're going to have like a strong impact on them. I think I skipped some of the slides, but you can still ask me questions about the slides because of the sake of the time, I cannot cover everything. So you can still ask me questions. These are my references, as you can see here. These are some of the references. If you want more, I can send you the references. Whoever wants more of the references, please ask me. I will send them to you. And I think this is the end of my presentation. I wanted to spend more time explaining the concept, but for the sake of the time and also for the sake of I feel like I'm presenting in an empty room. So because I don't see the participants, so I didn't feel like I'm presenting in front of an audience. But I'm hoping that they got the message. And also, I'm very sorry that I wasn't able to explain things in French. Je sais que c'est pas facile. C'est pas facile d'expliquer. Mais les questions, je peux répondre aux questions en français. I can answer the questions in French. They can ask me in French if they want, I can answer in French. But the presentation is not easy for me. It wasn't easy. Yeah, thank you very much.
Thank you very much, Yacouba, as well. It was a very interesting presentation. So thank you very much for having you once again. So dear participants, feel free to ask whatever question in English or in French as Dr. Yacouba has just proposed. Yeah, some participants have asked if they can have the presentation, if you would mind to share it.
Yes.
Great, so we'll just upload this the PDF file together with the recording of today's webinar. Thank you very much.
Okay. No problem.
Are there further questions?
Are they going to type the questions or orally ask their questions?
Yes, like most of the time they will write it in the chat box in the right corner. But if they want, they can also indicate that they want to speak directly.
Okay. I can also answer questions even after the presentation because I know I can, once they get the presentation, they can go over the presentation and follow up with questions. I'm okay with that.
Yeah, thank you very much.
Yeah.
I think they will highly appreciate. So I see several people typing, so let's wait what question they have got.
Sorry?
I can see several participants typing the questions, so just...
Okay.
Okay, I can see a question from Thierry asking, you have mentioned among types of poles, wood pole. What do you think are these in regard of the environmental aspects?
Type of call? What was the question again?
Of pole. You can see the questions as well in the...
Where is it?
In the chat box, in the right margin or corner.
Okay. Yes, I see. I can
go
through. Okay. You're talking about the participants. Welcome. Okay, that's you. Thank you. Okay. Did you say Shari? What's the name of the...
Jerry, yes.
I cannot see the question. I know there are many questions here. Okay, sorry. Yes.
I started with the...
What did he say? Okay, he says you have mentioned among types of poles, wood pole. What do you think about this in regard to the environmental aspects? Yes, he's talking about the wooden poles, right?
I guess so.
This is, yes, wooden poles, as we all know, we are advocates of the environment. Okay, we are advocates of the environment. Unfortunately, electricity is started with wooden poles. Means the beginning of electricity, wooden poles was there because at the beginning we didn't think that we will come to today's situation. So poles been there, but more and more countries are trying to, by all means, to avoid poles. Wooden poles, I would say wooden poles. Why? Because for you to get a wooden pole, you need to cut a wood. You need to cut a tree. But some countries, they plant the trees purposefully. They plant the wooden poles purposefully. So it's not like the wooden pole that they're going to go to the forest and chop a wood and come and get it, say, okay, this is my electricity pole. No, they plant it in purpose. So it would take maybe 20 years, 15 years, 10 years. It depends on the type of tree that we talked about. So it will have definitely negative impact on the environment for sure. There's no doubt about that. Does that answer the question?
Maybe Cherry, you can
If he
indicate
needs
if
more,
this
okay, more
has answered
specific,
the
then he
questions.
can specifically add. Yes, type it, please.
Type it. Yeah.
Another question?
Yeah, in the meantime, you can. Mamadou has asked, what are the challenges for my country,
The challenges in
Mali?
terms of what?
And it's also a general question, so maybe Mamadou, you can also reframe or give some details. What do you mean by that? And there's the third question by Alfred. What is the place of GIS in the distribution of energy?
The place of GIS?
Yes.
Well,
yeah. I just noticed there might be something.
Who's talking? Anyone? Whose voice was that? Is it participant or not? Oh, okay. So let's talk about the GIS. The GIS actually, we did some studies. We did some studies with GIS. With GIS, one of the things that you can do that one of my master student did was to be able to look at the niches where you can put solar PV panels, for example, the good niches. So you can use GIS to locate those niches. You can see that where, if you put a solar farm, in terms of, for example, dust, in terms of the amount of energy that you can harvest, in terms of the nature of the land, GIS can help you to sort out that. GIS can help you to locate the best place where you can harvest the most of the solar energy. So I don't know if that answered the question or not, but GIS can be used, in electricity, for sure. Yeah.
Thank you for the response. There is another question by Abu Bakr, who asked, with the ongoing wide adoption of solar energy by private users, do you think that we can adopt the prosumer model like some European countries to handle the energy?
If we can what?
You can see the question in the chat box as well. If we can handle the energy demand.
There's a background noise. Again, most African countries, the problem we have today is the infrastructure. The infrastructure is aging. So at the consumer side, a lot of work needs to be done at the consumer side. If we really want to see renewable energy coming to the grid, if we want to see, I don't know if I got the question or not, if we want to see a renewable energy coming to the grid, that's the photovoltaics. I can decide to have photovoltaic, in my house or on top of my roof to have PV panels, okay? Now, does it mean that the country or the authorities or the utility company will allow you to connect that energy infrastructure onto the grid? For now, the current situation, because we're talking about Mali and Niger, I don't see that happening very soon. I don't see that happening very soon. Because for that to happen, we have to have a kind of liberalization. We have to have a kind of place or system where the utility company will encourage consumers to have their own backup supply. Still today, it's a big problem in some areas in Niger where the utility company is not let go the monopoly. is not let go the monopoly of the electricity production. So having your own electricity production is good, but connecting it to the grid is another story. Up to today, I don't think that is happening in Niger. I don't see that happening soon. But hopefully in the years to come, we will see that happening in most of the countries, so we can have a new model where the consumer will be able to manage his own or her own consumption of electricity. Will be able to sell electricity to the power company, or will be able to get incentives for installing the PV panels on his or her roof. Thank you.
Thank you. I can now see that Mamadou has given some details. He says, what challenges are in terms of access to solar energy? And he referred to
What
Mali
challenges?
as example country.
Okay, let me see. The challenge is, first of all, the biggest challenge is economy. Is the economy. That's the biggest challenge, the economy. What I mean by economy is the household. For a household to access the solar energy, they must have some level of, I wouldn't say luxury, but they must reach some level. We know they have to be middle class. If we're talking about the country in general, that is coming. It's coming. I can see some changes happening in rural areas. The power companies, are installing solar panels in the rural areas. But for that to happen for individual level, it's going to be a big challenge because, again, as I said, the economy, the purchasing power, how much energy, how much money we have saved as citizens, and how much are we willing to spend on solar energy. Few people, we have some privileged people that can do that. But for the general population, that's going to take some time. The challenge is, again, on top of that, we have the technological challenge. We don't have the expertise today. We have some people, but we don't have enough expertise in Mali and Niger to allow us to spend to spend money and installing on PV panels. The technology still expensive today. Somehow expensive for us. It's still expensive, but some people no. In some countries, for instance, it's incentivized. Means what? The country will give you some comment je veux dire, incentives in French. C'est-à-dire the power company or the authorities will help you to install the PV panels, and you can pay that on installments. You can pay your installation in, let's say, 15 years, 10 years, 20 years. Some people can have a bank help them to install the PV panels, and then that goes. But that, I don't see that happening very soon in Niger or in Mali. Thank you.
Thank you very much again. I see maybe one last question by Thierry. What is the way forward to make?
Okay, so we want to make the African energy supply, I would say, let's focus on the electricity. We want to make the electricity supply resilient, or the power company resilient. So resiliency again is, the basic definition is that the capacity of the company, the capacity of the power company to spring back after a major disturbance. And what is the major disturbance? The major disturbance could be when, let's say, a big consumer is disconnected from the power company, or when a big consumer is connected. So that both ways could be considered as a disturbance. Okay. Now, when a disturbance happens, in terms of when we go back to basic physics, when a disturbance happens, you have a force, you have three forces. 3 forces, and you have a weight suspended. If you cut one of the ropes, what happened? The 2 remaining ropes must be able to support the weight. So likewise, for power companies to be resilient, we must have a diversity in terms of supply. We must have a diversity in terms of supply. We must have, let's say, if some countries, they have coal, they have uranium, we must have coal, we must have uranium, we must have, let's say, natural gas, and so on and so forth. And if anything happened for one of the generation stations, what happened? The remaining generation stations must have the ability to handle the remaining load. So for African continent, for mostly, let's say, West African power companies to be resilient, we must first change our infrastructure. Not change completely. Some countries, yes, it's a complete change. I don't want to mention countries, but for some countries, the change is supposed to come first from the infrastructure, which is the transmission lines, the poles, everything that we talked about today. They need to be upgraded. So upgrade is the key to resilience. I hope that answered the question.
Thank you very much again. So I think it's now time to close the webinar. So if there are some further questions, feel free to send them to the infos@rasus.com email, or to Dr. Yacouba directly, as he has proposed.
Okay.
Yeah. So thank you very much.
So they can
again
send their questions in French or in English. It doesn't matter. So as this I can answer. There's no problem. Okay. Thanks for having me. Thank you all. Bye. Thank you very much.
Great. So thank you. Thank you very, very much again. And for the participants, I would say bye to you now, and I guess we will see each other tomorrow morning for the welcome remarks and Q&A session again.
Okay. Thank you very much.
Thank you very much to all of you, and have a nice afternoon. Bye.